That's a great shot.
Okay. Okay. Can you see it?
Now
Yeah,
you can
it's
see it.
holistic
Okay.
approach.
Yeah. No, I think what happened is it got overridden by the other screen. Okay. A lot of these slides, I'm hesitant to go into the slideshow mode. Let us see here. Yeah, okay. You can all see it now, right?
Yes.
Okay. Yeah, I have kind of made like two types of presentation. One going into the details of the work that I've been doing on cybernetics and brain modeling. But I noticed that most of you have endured painfully through those slides. So I decided not to share those things. And I just have only 2 slides that I want to go through, trying to get as close to what Lou was talking about, get to the same theme. But the way I approach it is quite different, and it'll come across very disjoint, but that's the way it's going to go. So what I want to say is I've been working on understanding the human brain evolution. Then I realized the human brain is an open system, which means it is communicating with things outside the brain itself. And how do we understand the evolution of such systems? And been using cybernetics as a way of understanding that. And then I went further into this research, and what I'm doing now, I'm calling it as a holistic approach, and I'll discuss that in the next slide. And then in trying to keep some continuity with Lou's work, I'm starting with the same, the C.S. Peirce notion, trilogy of sign, signified, and interpretant. But I'm going to kind of reword it as a sign is a transformer, the signified is the observed, and the interpretant is either an observer or a doer. That is, if this self is doing something, then the signified becomes the recipient. And if the signified is doing some work, then the interpretant becomes the observer. And from there, I'll build the case and talk about what this statement means. So I'll start with the what I call as the holistic approach to cybernetics. So I think we have to kind of look at 3 different aspects. The first one is to define what is a system. A system is a collection of interacting discrete entities, subsystems, exchanging matter, energy, and information between themselves or with the environment in which they are operating. So the key point here is there are no systems in isolation, and systems are interacting with other systems or with the environment. So that is what I'm calling as an open system, exchanging matter, energy, information outside its boundaries. Then the way I want to look at this system is using a systems thinking, which is to formulate it as a dynamic trilogy of interconnected 3 different aspects. One is information. The second one is structure, which is an assembly of matter. And then the third one is the function, which is functional activity. Jason, I'm not defining it as function as in software or computer science lingo. This is more as a work done or activity. And this is a structure assembly. And how the 2 relate to each other is what I'm calling as the information. And then given this, how do we define cybernetics? So I'll start off with the definition, which is cybernetics. Think of it as a self-organized, reciprocal control and communication between complementary entities. So there are 3 different now keywords here. One is self-organization. Then the second one is reciprocal control and communication. And the third one is complementary entities. So I can shorten this longer sentence into even something smaller which is information processing by the self, of the self, for the self. Okay. Intentionally, I tried to keep some similarities in color. That is, information is the reciprocal control and communication. And self, I'm defining it as a complementary entity. And if we're talking about a living being, then the self would consist of a body and a mind. Then the processing is the self-organization process, and the purpose for which it is doing it, it's for itself, by itself, of itself, for itself. So how did I come up with this definition? Of course, by standing on the shoulders of great legends here. So first of all, Norbert Wiener, who started this, coined this term cybernetics, he also defined it as control and communication in animals and machines. So the first part, control and communication, what I have here, and I think of that as information going back and forth between the complementary entities. So what is common between animals and machines? I think it was probably focused on the control systems, and he has written a lot of pages in his book about the brain architectures and living beings, and where I presume he studied mind-body. And he extrapolated that to machines by saying that the machine is doing something inside itself, and we can put a controller on it. So we can break the machine then into the body and the mind being the controller. So I'm assuming that his thought process probably is to equate these two things to self. So that is why I took this definition and redefined it as information processing for the self. Then if you look at Norbert Wiener's another statement, information is information, not matter or energy. So that, again, you can take this as matter and energy is what constitutes the self, because self is made up of body and mind. Body is real matter, and mind, if you think of it as function, doing some work within whatever hardware substrate it has, or controlling the functions in the body, then that is the equivalent of the energy. And so the self is not the information, but what it does to communicate between its two different aspects is the information. So this statement is consistent with this. Then I can look at what, I don't know how to pronounce his name, Greg Bateson. Cedric? Korfsky? Yeah,
Kozlowski.
Kozlowski, okay. Kozlowski, okay. The statement here is a map is not the territory. That is really the very key statement here. Again, if you follow the blue will take you to self and complementary entities. That means that these are the things that we are trying to study, and the map is the information. So map really does not do a full justice of the territory. That is, everything that are in the self are not really captured by the representation. I'm assuming that is what they meant. And the part of the reason is the mapping process or representation is contaminated by the filtering and biasing due to the emotion and association by which we create these filters and biased representation, and that changes the true reality. So that is why the true reality is not the same as a representation. That's how I read this. Again, this is kind of consistent with the cybernetics definition I'm looking at. And then the next interesting thing is information is the difference that makes a difference. So here it is the relationship between the complementary entities. Again, the first difference inside the loop here, that I take it as the complementary entities, and then studying about them, what is the relationship between the body and the mind, the two aspects of the self are the two complementary entities, and that relationship is the difference of the information. So essentially, we can look at many different definitions and try to capture it all with as much as possible, just one phrase or one sentence. This is the goal of my presentation here. And the reason why the map is not the territory is because the meaning of the scenery is defined by the resolution limitation. It's not only the filtering and biasing, but the observer may not be able to capture all the details of the scenery that are existing in the reality. Therefore, what happens is the observed reality becomes a subjective interpretation. I presume this is what Lou was talking about earlier. So this is in the last meeting, we were talking about all observations are actually subjective interpretation, because the true reality is not something that we can see. But what, for example, if the light that is falling on an object and coming back into the retina, and that changes the state of my body organ, and that is what my mind is going to, or my mental cortex is going to interpret as a scenery. And there is so much resolution limitations in between. And so the whole thing is subjective interpretation. But if all of us in this room agree to look at something and say that is what it is, then that we call it as an objective notion, but everything is subjective. And also, Lou showed this statement by Hans-von Förster. I am the observed relationship between myself and observing myself. So here I'm interpreting this as, when it says here, myself as body, observing myself is the mind observing my body, and the body is observing the world. And the information then is the observed relationship between this and this. So again, you can see everything kind of goes back to this statement. Its information is not matter or energy. Information is not synonymous to the self, and it is a biased representation. So then the rest of this statement here, we talked about the information and the complementary entities, and what is the self-organization process. So the self-organization process, this is where I spent a lot of time trying to develop a physics type model and a mathematical model. And the model here is the body has, it acts, senses and acts locally, whereas the mind cognizes and thinks globally. So this is a physical part of my system. It's a hardware, and this one is a conceptual part, and it is really dealing in a totally different symbolic space. So you have a hardware space and a symbolic space, and this is sense and act locally. This is cognize and think globally. Together between sensing, cognizing, thinking, and acting, and then acting leading to sensing, that whole loop becomes the self-organization process by which I'm developing my notions, okay? And what is the process that underlies this? The cognition and thinking is a fast, discrete, long-range, selective control process. Again, this would all make a lot more sense if I were to be talking about brain and go specifically into the brain hardware. I can explain these things better, but I can just take this as a generic description. So there is a fast, discrete, long-range, selective control, and then there is a slow, continuous, local, broad communication. This would make more sense when I go a little further down here. So what does this do? The local state changes, you can model that as the local state change, meaning the let's say we are talking about a stimulus going from outside to inside, then the body state changes, you can think of it as a continuous exponential process, whereas the long range effects are the fast, discrete Poisson process that is coming in to affect the state. So the two together, there is a dynamic interaction between the state changes and the long-range input. And the two, when the two together, there is an emergent process. And again, there are, every one of this is a slide, but I'm not going to discuss those. We have seen most of them. That emergence, it can happen in three different ways. The exponential process itself could be dominating the state change, then it can be an exponential decay, or it could be an oscillatory phenomena, and that is where you get the eigenvalues and the system response and those kind of things. So when you're talking about a self-organizing system, one way is it can be a oscillatory or a first-order system doing whatever it wants inside the system itself if it is dominating. Or if the external load or the external input is dominating, then that would just become a forced response, and that is one thing. So these two are the classic Newtonian dynamics or the classical dynamics that we're looking at. But the third possibility is, instead of being deterministic, the state change could be a probabilistic event, the probability-based joint process between the exponential process and the discrete Poisson process. And this interaction happens one step at a time. That is, as soon as an interaction happens, the system state changes and the input is also changing. So you're starting all over again at a new process step. And the way what I've seen happening in brain based on the experimental data and the fit that I've been able to do to that is it breaks into two parts. The initial part is when the signal is coming, you have to differentiate it into parts. So in object recognition, you would call it as feature detection. Then you have to integrate the features into an object, which is integrating into the whole. So the interaction is modeled as a differentiation integration, or a parts breaking into parts and combining it into a small whole. And then that in the next process step, you again break this into parts and then integrate it. And you keep on doing recursively until you get to a super concept. So at every stage, you can be getting a new object or a concept and keep building on that. So this is the dynamic interaction that happens through self-organization in a system. And that's what I'm calling as a cybernetic process. And the modeling, the space, actually space is kind of a misnomer. Space is really nothing. What we should be focusing on is the matter that is participating in the system. So instead of space, it should really be, instead of space state, we should be calling population coding. And the state is the change in the system at discrete intervals. So population coding over temporal changes, and that is how the system is working. And when you go through all of this and cast it into either an algebraic series or into a matrix formulation, or go into a statistical formulation using the Poisson process and the exponential process, all of which I had shown in the past. When you do any of those things, interestingly, you come back with the same answer, that this process really follows a simple geometric progression at each step. And the scaling factor is really the golden ratios. If it is an expanding system, you get the 1.618 golden ratio. If it is a decreasing a system, then you get the inverse of that golden ratio, minus 0.618. And the beautiful thing about the golden ratio being the scale factor, that is, the scale factor is independent of the observation dimensions of the observation units. And when you use that, or when you recognize the scaling happens by golden ratio, the beautiful thing about it is it's very easy to implement. If you do an additive implementation, you will get a multiplicative answer. Why? Because 1 plus phi, that means if this is happening at a rate of 1 and this is happening at a rate of phi, that being the ratio between these two steps, then at the end of this interleaved combined step, 1 plus phi will give rise to phi squared. So you start, and then if you multiply this by phi, you will get a phi cube here, because the next step is phi plus phi squared. Then you'll get phi squared plus phi cube, etc. So at every step, the process is doing only a simple addition, but the output is a geometric progression. And so within very few steps, the size of the systems can expand enormously. And that's the beauty of golden ratio. And that appears to be very interestingly happening in nature, which is very ubiquitous in nature. And another interesting thing is the phi squared is 2.618. And if we convert this into radians, pi radians is 180 degrees. Phi squared is 2.618 radians is 137.5 degrees. And that angle is called the golden angle. And you see that in nature, many, many places, how the leaves shape up and what happens inside sunflower and all those things. In many places in nature, you see golden angle, you see the golden ratio, and the number of leaves that come out of a plant, they follow Fibonacci series. And we can say a lot of these things start off from a self-organizing cybernetic process that we're defining here. And in the previous presentation, I talked about how this control and communication are done by excitation and inhibition in the brain. Moving on to how the brain evolution through cybernetics, I think the brain evolved to reduce uncertainties during interactions. In other words, it is helping the self to observe the reality and construct a model. So it consists of the brain can be broken into two parts, a body domain that interfaces with the sensory motor organs, and a knowledge domain, which is doing the symbolic processing. Interestingly, you can't go from raw energy type of domain to just as symbols. You need an interface within the brain itself. See, the brain is an interface to body and mind, but within the two brain parts, we need an interface. And that is how everything becomes very recursive. And you can take this argument down all the way to the microtubules, proteins levels, and molecules level. But staying at this very high level here, what we are seeing is there is something in between the body domain and the knowledge domain, and that is the one that is converting the input from the sensory motor organs into pulses, discrete pulses. And once you get pulses, you can sequence them like a barcode, and the barcode can be given a label, and the labels now can be combined. For example, the labels could be the words, which are nouns and verbs. You can combine a noun and a verb and make a class. And from the class, you can make add adjectives, adverbs, make sentences, then into paragraphs and stories, and go on and on. So that is expanding the knowledge. On the other hand, if you go down, the word itself can be broken down into syllables, and syllables can be broken down into phonemes. Phonemes can be broken down into some receptors inside the sensory motor organs firing. So you can keep going, drilling down onto the low end, or you can keep going up in the symbolic processing, going all the way to linguistics and other things. So we can see that the starting point, saying that the brain has to do two things. One is observe the reality, that is, it gets the energy from the real matter from outside, or even from inside, from the internal organs, and converting them into pulses, and then processing the pulses with the back end of the brain, symbolic processing, which is same as constructing a model. This becomes a nice closed loop. So this is the brain model that I've been working on. So how does the brain work? It goes through three phases: learning, memory, and recall. And this is how it becomes the interface between the body or the world and the mind. Now, what is learning? Learning is a salience and valence. That means how important it is, and then is it a positive input or a negative input? Does this cause craving or cause aversion? That is the valence part. And then the salience is the importance. And that has to be assigned to a mapping of reflexes, and that is the learning process. And what do I mean by reflexes? It is pairing of sensation and action as reciprocal dynamic attractors. So the key point here is, you can see I'm calling brain as a mapping tool. It is not a computational tool. It is not knowing arithmetic or algebra or any of those things. It is taking the nerves that are coming in with the sensation and connecting them to nerves that are going to take commands, go do some actions. It is the mapping that is the job of the brain. And how does this do the pairing? That the critical point here is you cannot start this pairing when the brain cannot as on an empty list. That is, when the baby is born, the brain is not a tabula rasa. It's not empty slate. It is really, baby is born with a lot of primordial reflexes like hunger, thirst, fear, and then a lot of take the hand near the eye, it will close the lids, and there are a lot of reflexes that the baby is born with, and all we have to do is take those reflexes and start to associate them with new sensations or new actions. Once you do that, you can build now a memory sequence. So the learning is basically pairing a new sensation or action to the primordial reflexes and making them into, and then assigning them salience and valence. And this is the learning part of the brain. Then the memory part is, once these connections are established, they are established in two ways. One is through neuromodulators, which are really short acting, and that is what we call a short-term memory. And that keeps, depending on the strength of this memory sequence, it can stay on a very short period or even keep going on for a day or two. And that is maintained by the neuromodulator secretion. But if it is, the memory is really of a lot of importance, then that becomes a long-term memory. And the long-term memory is done by making epigenetic changes to the DNA, by doing either demethylation or methylation, and also changing the amount of activators and repressors. This is actually a very nice paper that came out of MIT today, and they show beautifully the epigenetic changes, how the DNA changes on cells, in generic cells. And the neuron is nothing but a cell. And so the brain memory is also following the same sequence. And all the other cells in the body too, they all have memory. Every cell, the DNA is the memory, and the memory goes through the same epigenetic process. That's the learning process that happens in all the cells. Then the third one is the recall. And the recall is reproducing a comprehended knowledge step by step from a memorized procedure or from a hierarchical sequence. So during learning, we created an associative memory sequence, and that is stored in short-term or long-term memory. And through an internal stimulus, we can recall any of those memories, and those memories basically are played out. And I've shown in the past that this is like a motor process, and shown the matrix relationship and how only the motor commands need to be stored in the memory, and we should be able to reproduce any of the past experiences, because sensations cannot be created from within the body. It can only give action commands from the mind. But that is all you need, because every time a command is issued, an action is issued, it immediately has a reflex action. It creates a sensation. Sensation has a reflex action to get the next action. And it goes on and on. So all you need is action, 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 action. And we can start from the highest level of concept and go all the way to the lowest level. So this is how the brain evolved. Again, all these things I'm building with the same notion of the cybernetic process that I started off in the first slide. So now, how did I get to this point? Again, reading and thinking about a lot of different people's other researchers' work. One very interesting thing is Margaret Mead on the very first, I think, the ASC conference stated cybernetics should be looked at, should be considered as a way of looking at things and as a language for expressing what one sees. So what is interesting is if you look at this, looking at things leads to sensation. And a language for expressing what one sees, expression is action. So essentially cybernetics should be looked at as a combination of sensation and action. And this mapping is done by the interface, the brain, and that becomes the basis of human cognition and how we go about doing our behavior. So it kind of, it all points back to the same thing. And this is the statement that Lou showed, and I briefly talked about in the previous slide. I'm the observed relationship between myself and observing myself, which is the body and mind, and then the relationship, meaning the information, which actually becomes memory. Then the memory-guided activity is what we see as a body-mind reciprocity through the brain, and that's a cybernetics process. You can look at this using the C.S. Peirce's language type of definition, where we are seeing three different things: a sign, signified, and interpretant. And that's what I talked about in the last slide, that the sign is a transformation of physical input into a pulse sequence. We can think about it that way, and then we can assign the pulse sequence a label. Then for the signified or the observed entity that is doing existing in reality, dealing with matter and energy here, and that becomes a pulse sequence interpreted in the midbrain and assigned a label by the interpretant, which is the higher level cortex of the mind.
Ram, you need to speed up.
Okay, this is the second slide. This is the only slide I have. I'm done. Okay. Finally, what we're talking about, you can skip these things. Okay, why do we need body and mind? This is where some of the work that Lou was talking about, which I understood from reading his paper, is formal systems that are consistent cannot be complete. That is, if you're looking at the mind, and we are looking at symbolic manipulation. Symbolic manipulation is a complete system, but it starts off with axioms and rules. And when you use the rules themselves, everything looks consistent. But when you start to challenge the axioms, how did things start off in the first place? The logic kind of breaks down. And that is where you need to go from the mental aspect into the body aspect. That is, it is really the real material input that got changed into symbols, and you're getting symbolic manipulation here. So the mind without body or body without mind is not a complete system. And we can sort of claim that when the two are consistent, then the information is real. And that is how the courts work, right? Okay. And I can take this same cybernetics discussion and show how it works in the evolution of governance, evolution of language, and the evolution of how what is consciousness, all of those things I think talked about before, and these are all in the slides which I can share. So conclusion is the living open system model, it needs a self-organizing interface, namely your brain-like interface, which contains nested parallel processes operating at various space and time intervals, and their goal is to reduce uncertainty. Essentially, body gives you the position and mind gives you the velocity or the change. And once you have the position and velocity over a small spatio-temporal range, you reduce the uncertainty and you can move on from current step to the next step. So small incremental steps you can make with this body-mind architecture. And that's how it enables interaction between systems and their environment. So then the big question is there a plausible singularity in the universe? So is this the discrete matter in motion? And then what we call as continuity, is it really a construction in the mind? This construction is necessary for survival in the now and to adapt to changes. If you cannot construct your model saying that this car is coming very fast towards me and don't jump, we'll get run over. So construction is necessary, but it has to be based on this discrete reality. Okay, so this is what I wanted to say. Thank you.
Oh yeah.